Hey everyone, welcome back. Today's day two of my 30-day FAANG grind, and I'm trying to solve 6 to 10 LeetCode problems daily. Where I'll be breaking those problems into a video, and I'll be sharing my preparation and techniques and insights of those problems in those videos with you here on YouTube. I'm Divya, by the way, and I have interned at Massachusetts Institute of Technology, where my area of focus was machine learning and statistics. Currently, I rank in the top 0.2% globally on LeetCode, and I am aiming for FANG interviews like most of you. Yesterday, we crushed some sliding window basics, and today we are diving into two-pointer techniques, which is absolutely critical for FANG interviews. We will also mix in sliding window variations to keep flexing those patterns muscles, okay? But before we begin, I have a request. If you find this video helpful, please drop a like, share with a friend who is grinding too, and please hit subscribe so we can crack this interview together. Let us go. So I'm assuming this is the eighth problem for today, 283 on LeetCode, and the problem states we have been given an array that has positive integers. No, okay, the integers can be in the range of negative or positive, it do not matter. So what do we have to do? We have to shift all the zeros towards the end of the array without taking any extra space. Let us move to the dashboard and we will try to investigate and try to arrive at the solution. Okay, so this is the dashboard we have, and we have been given nums array, and our objective is to move all those zeros towards the end in such a manner so that we don't interrupt or change the actual order of the elements. For example, if we move all the zeros towards the end, the order must be maintained, and our new array will look something like this: 1, 3, 12, 0, 0. So how do we reach here? Perfect. So we will be using two pointer. The one pointer, it will look at the last index where we had the 0, and the second pointer, which is an iterator within a loop. Okay. So we start from 0th index and we ask ourselves, hey, is the number present at 0th index where the ith iterator is pointing at, is it not equal to 0? Hmm? If it is not equal to 0, then we do something. If it is equivalent to 0, we don't do something. We don't do anything, but we just increment the ith counter, which will eventually anyway increment on its own because it is an iterator, right? So I come to this part. Index I is here. I ask again, hey, is the value present at that index? Is it not equal to 0? And the answer is yes. The value at this index, it is not equivalent to 0. So what does we do? Remember, our goal is to shift all the zeros to the right of the array and all the non-zeros to the left of the array. The index right now where we are at, this is non-zero. We must shift it to the left. Now, where do we shift it to the left? We shift it to the last position, which is denoted by L index. How do we shift it? Should we just export it there? No, we make a swap. We make a swap between the value of the ith index and the value of the L index or the last index. And when these are swapped, it will become something like this. It will become 1, it will become 0. And when the swap happens, we increment the left pointer or the last pointer and we bring it here. The ith pointer, it automatically increases and jumps to the next part. It asks again, hey, is it a non-zero value that I'm looking at? And the answer is no, because it is a zero value. We do nothing. This comes here. Hey, is it a non-zero value that we are looking at? Yes, it is a non-zero. What do we do with non-zero? We move all the non-zeros to the left and all the zeros to the right. Since I am at a value which is non-zero, let me move it to the left. But where to the left? We move it to the left at the last index position, which is denoted by L index over here. How do we move it? We make a swap. We swap 3 with 0 and 0 with 3. So it becomes 0 and it becomes 3. Okay. And when the swap happens, we increment the left pointer by 1, left come over here, and ith counter, it automatically jumps to here. It asks again, hey, is it a non-zero value? And the answer is yes, it is a non-zero value. What do we do with non-zero? We shift it to the left. Where to left? To the L index over here, right? We swap it with that value, correct? 0 becomes 12 and 12 becomes 0. If you look carefully, this is pretty much identical to what we wanted to achieve, okay? And this is the way in which we can achieve it. We just need to keep track of two things. Move all the zeros to the right, move all the non-zeros to the left. But in order to move all the non-zeros to the left, we must have a pointer to the left that must be assigned to a position where the non-zero value must be moved at. And in this case, it was the left pointer denoted by L, right? So let us go to the code. I have declared a left pointer and I will call it last. And this is the ith counter iterator within the loop, and it will run across the length of the nums. I ask myself, hey, is the number that I'm looking at, is it non-zero? And if it is non-zero, move it to the left, right? Left move. How do we move it to the left? We don't just export it. Instead, we make a swap. That is what I'm doing over here. We are making a swap between the last index and the ith index. This is how it is done in Python. In your language, it might be different. And once that is done, I increase the last pointer by 1. Okay. And once the loop is executed, we return null because that is what the problem asks us to return null. And what is time complexity? Time complexity, as is prevalent over here, is order of n, which is linear because of this loop. We don't have any space, extra space apart from this constant variable that we've declared. So space is constant. So that is all there is to this problem. Let us move back to the lead code dashboard. Yep. And I have to type this. Give me a second. Oops. Okay. I forgot to copy, but anyway, I'll copy it. Last 0 for I in range. This video should not be this long. I ask, hey, is the value that I'm looking at, hey, is it non-zero? If it is non-zero, then please do me a favor. Oops, and please swap it with the last index. Come on, don't mistype nums of last. And once that is done, I will increment my last by 1 and return null. And as you can see, it passes all the test cases and our problem has been submitted. This was, honestly speaking, a very tricky problem, no doubt, but I hope you enjoyed my explanation and I will see you in the next video. Okay.